Okay, I'm Jared Huffman. This is Weldments. How many of you have used Weldments before? Okay, awesome. So this will be, we can get into some good stuff. I've been using Weldments for a while, and I find a lot of people have resistance to them because maybe they didn't work several years ago, or they're scared of them. But I really like them. They're a very versatile multi-body tool. First thing I want to talk about is assemblies. So when should I use assemblies versus multi-body parts? What I have here is that's one part, and these two gussets are a separate part. And the reason I separated those out is because my company, and this will be different for anybody, wants this to be a special part number that we can plug in all kinds of different assemblies all over. They stock it on the shelf. So I put that in at an assembly level, and I would call this an add-on weldment assembly. So you can use the two together. You could also assign part numbers in your weldment cut list to any member or any item in on your individual part. But if you want the flexibility, it's nice to have it separate. Another reason you might separate things out is for modular design. If you have some frame that, no matter what frame we put it on, there's a little stand here that's going to always be the same, that would be a good case to separate it out also. And when implementing weldments, make sure to talk to the rest of the people affected by your documents. Like he was saying, it's not just engineering that opens these files now, so make sure your purchasing and everybody else knows how to deal with weldment files. That's been a lot of the resistance too as well. I don't know what to do with this thing because I'm used to single body part files as a purchaser. So work with them, make sure your drawings are going to be helpful and something usable for the entire company. By the way, please feel free to stop me and ask a question if you have something that comes up. I'm hoping that we'll have time at the end for other questions too. The principal element of a weldment part would be a 3D sketch. I advocate starting every weldment with a 3D sketch, simply because if you start with a 2D sketch, you can't turn that into a 3D sketch later. Even if you just have a little box, having a 3D sketch gives you the flexibility to add that third dimension throughout the life of the part. SolidWorks is completely flexible to let you use multiple sketches, 3D sketches on top of each other with planes. I like to keep it simple and keep it all in one sketch as much as possible. So let's talk about the sketch a little bit. Sketching, a lot of basically 3D sketching is not that different than 2D sketching. There's a few unique relations that you can use, but you just have to get used to dealing with the 3D and knowing which direction you're drawing your line or your sketch entity. A nice thing for that is the tab key to switch between X, Y, Y, Z, and ZX as the direction that you're drawing. So I'm just pressing the tab key there. A tip that I use is to only have one sketch entity for each along axis relation. When you start drawing, see how it's automatically adding the along Y. Next time that's along Y. This is a powerful mate or a relation. And something I've just found through experience is that setting up one along Y and then putting all of my other sketch entities parallel to it is a more robust way to design a 3D sketch. It's kind of handy too if you decide you want to rotate this whole thing. I know I only have two relations I have to change, and I can actually turn this entire thing 90 degrees relative to my coordinate system.
you turn off the auto relationship to do that, or do you draw it purposely off from not on X or on Y or what?
I draw slightly off so that I can.
And add that with parallel rows.
You can also hold down the shift key, shift, and that will temporarily. No, not shift. Control. Hold down the control key to temporarily disable those automatic relations. You want to make sure that you're sketching to design intent. That should probably be mentioned in every SolidWorks presentation you ever go to, but the nice thing about the way that I've got this dimensioned here, I would never, a lot of it wouldn't show up on a drawing quite like that. But if I wanted to, say, make this a foot longer, the stuff that needs to stay relative to this end moves with it. And that's just basic design intent. But see, this 18-inch here, if that's for an 18 by 18 electrical panel that mounts there or something, and I wanted it 6 inches taller, I'm only changing, whoops, I'm only changing one number to make it taller. I only have one dimension for the length of all my feet. They're all set equal to that one. Another principle is use least powerful relations that you can. The hard thing about 3D sketches is it's a pretty complicated thing to solve, and it's a pretty complicated logic puzzle to go through and find where the mistake is or where the over definition is happening. So if you're drawing and where I want to put this line just happens to be the midpoint of that, here, let me think of a better example. If I want to put a midpoint across these two, there's the midpoint, and I draw it over here, connect to that midpoint. Now automatically I have two midpoints and an along Z. And this is over-defined. It lets you get away with it, but if you try to move something later, it might blow up. And so this is where it's key to, if I wanted this to be parallel to my main construction line there, make sure you only put a coincident relation on this end.
I have a question.
Sure.
So what's new? Like, I thought this was supposed to be something new.
Okay, you want something a little more?
Yeah, it's like,
all right. Let me keep going through here, and I'll get some tips, and then if you have questions, we can get to those too. Resist chain constraints. So if you do a 3D sketch and you select 6 lines at a time and you say equal, it's going to set one equal to the next, equal to the next, equal to the next. And this is a problem because if you delete the middle one, now you have a break in the chain. And you're forcing SolidWorks to solve it in that order. So if you set them all equal to the one original line, then you have a more robust 3D sketch. Yeah.
Why don't you show your sketch relations?
They get crowded. I use a shortcut key so I can turn them off and on. But there, if you want to see them.
So just the visual effect of them not being there?
Yeah. Yeah, it's just cleaner for me when I'm thinking through my 3D sketch. This gets a little crowded. You can see how much stuff is constrained to my origin or to my main principal sketch lines.
so you use a lot of weldments?
Yeah.
Why? What's the difference between when you do like sketch-driven assemblies? I have found that to be more effective than this because that gives you all kinds of. You don't have limitations, and with this you have all kinds of limitations. So why would anyone want to use weldments
Instead of an assembly?
instead of like a driven sketch assemblies? So that's whenever I do this, I would rather do a driven sketch.
Right. So he's asking, what's the advantage of a single part weldment versus a sketch-driven assembly where everything is parametrically linked anyways? And there is some flexibility that you gain there, but there's also functionality that you lose. You lose some of your cut features and those kinds of things, but the most important thing is having it all in one file. So if
But you can, with driven sketches, and when you drive the whole assembly with just sketches, you can have it in a file. You don't need.
Are you talking about an assembly file with multiple parts used, referenced by that assembly?
Yeah, like a sketch driven the entire design.
So that may work well for some cases. I found that too. If you have top-down modeling in a situation where those components might get picked up elsewhere, might get used by other users and people, that's where we have big problems with that. Also, if you want the drawing, working with a PDM system, if you want the drawing to always be what it was when you release it, those are some questions you have to answer. It is effective in that. Another thing is, these are driven by one feature. So if I have, if you have a bunch of frame pieces like this, right, and each of those are a separate part driven by a sketch. If I want to change this profile, I only change one feature, one time,
Yeah.
and that controls the entire part. This actually happened to me recently. I designed a frame here and they said, oh, well, we're going to go to a different thickness of material.
Sure.
So instead of having to edit 30 individual parts, setting all of those thicknesses again, I only had to change a couple features that I had separated out. So let me show you that a little bit. This structural member feature is really powerful because you have groups. You can add as many groups as you want. I haven't run into a limitation on that. And these are automatically trimming within each of those groups within the structural member feature. So it's only necessary to trim if you couldn't fit it in one group, if they weren't the same profile, or you have some other dependency that changes that. So if I wanted to add a group, just click New Group, and say I added these three. You can add a group. A single group can contain entities that are either all in a row, all continuous, or all parallel. And you can see it's automatically trimming. And you have these purple dots where the functionality is you can change the way that it's trimming individually also. So if you have 3, 4 members coming together at the same time, you can actually change the trim order of how those members intersect.
Can you change, like one to be 45 and one to be,
Yes.
in a group? So you get multiple corners in one group.
Right, so if I don't have any place where 3 are intersecting here, but if I click this, I can switch just that corner to be a butt weld versus a miter corner. And when you have multiple, what it'll show up as is trim order 1, trim order 2, and basically it will do the first trim, and then anything below that will trim according to what's already there from above it. So if you bump something higher up in the list, it gets trimmed first. And 2 things that are the same trim level get mitered to each other. So you're just setting an order of put this beam in, then everything below it gets cut to it. Put this one in, everything below it gets cut to it. And you have individual control over weld gaps here too. Also, you can set weld gap at the group level here. So this is a weld gap within a group, and this is weld gap between group segments. Flexibility here, as you can see, I'm putting this in. Maybe I didn't want to put that on the center of my profile. Rather than mess with your sketch to try and offset it in the right spot and everything like that, there is Locate Profile. This button brings in the sketch. You can choose any sketch point on your profile Now I'm relocating everything to that spot, to that point. So I recommend in creating your own or editing your own weldment profiles, which I'll show you in a minute, go in there and add as many points as you can think you ever might want to use, because they're useful. If you think a shaft, maybe you only show the center point of it if you were drawing just the profile, but if you're using it for weldments, you're going to want points on the sides of it, maybe in the corners and all over the place, because that may be your design intent at one time. I want this along the face of something. The other thing about this feature is align. I recommend aligning every group. Even if it looks simple, this will just tie it down, so this profile is always going to be the 3x2 orientation you see there relative to the line that I just chose for alignment. You can click align vertical or horizontal to rotate it, and you actually have an angle control on that too if you wanted to show it at an angle like that. And it's doing the miter for that automatically. If you do have structural members, different profiles, or they needed to be separate features for some reason, that's when you get into the trim extend feature. You can trim to a plane or a body, and I recommend for this, as you're building your trim extend features, trim either between only one body or only one body to be trimmed. So if I'm going to pick a bunch of boundaries, generally it's nice to only have one thing being trimmed by them. If you get into more, if you're trying to add too much there, then it starts extending your other beams along with it, which wasn't what I intended to do. So that's just a general rule. You'll obviously break it at times, but it helps keep things simple and organized that way. Think of one beam, what's the stuff I'm going to trim with it, or one plane, what's the stuff I'm going to trim with it. That can be used to extend or trim your bodies. This one here, my 3D sketch, ended on kind of the left side of that structural member. Here, I'll show it there. There's my sketch. I use a trim to extend it right to the other side. Also on that feature, I stuck it underneath, and I could have done this with a 3D sketch by drawing a construction line down here and putting a number and having a line going across. The reason I didn't do that is if I change the height of this tube, that number would be wrong. And so this is actually stuck to the lower face. It's a sketch on that face, so that if I change this to a 4x2, that tube just moves down with it. End cap is just one example. You can do extrude or all kinds of any SolidWorks features onto this weldment as well. This is just an end cap that will shorten the tube. Have it stick on the end or shorten the tube or go inside the tube. And the reason I bring that up is for the purpose of the cut list. Another tip though, before I get into that, use mirror body. If you have something that's symmetrical, why draw double as much stuff or 4 times as much stuff as you need to draw? Just put your members in there and use mirror body at the end, and cut list will pick all that stuff up just fine. Alright, so the cut list for a weldment is actually contained in the part, and you'll put the actual table on your drawing, but it's getting that information from the part. And it's important to understand that, because if your part is not up to date, then the cut list on the drawing is not going to be right. So here's where it is. This is the cut list. Anything with this weldment symbol has automatic, the length is automatically being filled out for it. It's made with a structural member. This one that's showing as a folder is because that was the end cap, and it does not have the automatic properties other than quantity. Any body that's the same exact thing as that will show up and count correct in the quantity.
Is there a way to get the stock size of that end cap? We put, you know, you want the cutlass size.
Yeah.
We've not found a good way to get the stock size of that end cap.
Yeah, those dimensions aren't in there. You can link it to the dimensions of the tube if you wanted to,
Yeah, or a reference dimension.
or put a reference dimension on it.
Kind of like flat stock or something. Just
Yeah.
like that.
You can type that in here too manually.
Sure, but
I
I
li-
want to type it in there.
Yeah, I agree. I agree. It's so silly. They know that it's an end cap. They know what it's for. Why not have those dimensions
Specify the
available for it?
offset, it'd be nice if it automatically put in
True.
that opportunity to get that.
Yeah, I agree with that concern there, unless somebody else has found a way
Can you make your
through
own
that.
profiles like the tubes?
Yeah, you can draw a piece of bar stock on the end of it, you know, like a little vertical line or something, and use that. And then that
Properties
would,
on that, and that would do that.
yeah.
What I've reverted to in times past is to just start a sketch on the end of the end cap, convert the two edges, pull dimensions off of it, and then link to those dimensions.
Right.
The sketch will change with the end cap, you can link to the dimensions, it all works. And
Yeah.
you gotta insert a sketch and do two conversions.
Yeah, I mean, there's all kinds of different workarounds.
I agree.
It seems like
It's
that's a
silly you
simple
have to
thing
work
that.
around.
Yeah. I,
should have.
Right, you're gonna have end caps. I mean, it's,
so you could also, if you, depending on if your end caps are on the external, you could just put them in at the next level, at the assembly level, as a separate part that you have. But it kind of depends on how you're going to use it. But I agree, that I wish that was there. I linked this one to the thickness. The thickness is there. So this is what we're talking about. Why don't I get other dimensions besides thickness to use for this? So don't have an answer for that. We have some workarounds that have been shared. So you could do that with an extrude too, any extrude. You can link those dimensions into that property. Let me show how you do that. Just some of you know. But this is a property that I created, description. I'll do it live for you. You want to include a dimension from your model in a custom property or in a cutlass property. Basically, all you have to do is click on that dimension. You can see in the evaluated value it's using that. If I change the thickness of my end cap, that is going to update. And you can do that for, if I had a big plate stuck on top of here, I can add its length and width by clicking those dimensions, and it'll be linked as I change things. Those dimensions that show up in the cut list will be linked. You have automatically created configurations. This is a blessing and a curse because a lot of people aren't aware of the configurations. So if you don't know which configuration you're in, you might make changes and not realize that, you know, why did my drawing not update the way I think it should? But it's very nice and useful if you're going to use this weldment and send it out for machining. So you can have all contained in the one part file, the weldment before I drill holes in it, so I know that just because I drill a hole in this tube after the fact, it's not really different than this tube. And so if I use the as welded and the as machined configurations, that would be taken care of.
Keep in mind your cutlass is always driven from the as welded.
Correct. So he's pointing out the cutlass is driven from as welded, and I don't think it will even let you drive it from the as machined. So you can drive it from a different config.
Showing a detailed cut list, it's not driven from the as welded.
Oh yeah,
The bug
that's
that's
true.
been in there
Yep.
for years.
So let's look at the drawing. Couple functionalities I want to point out on here with the weldment. Here's the cut list. You can add columns, and these columns are driven from can be driven from automatically created properties. These are the default custom properties that are in there, and I went ahead and added on all of my pieces that have certain types of cut. I added a property called cut type and then entered in this information. So now you can look at the cut list and see, basically I was thinking, I was sending steel to be cut one time and they wanted to know without looking at the drawing which way are the cuts going. I know they're all mostly 45s and they're either all going to go like this or like this. So they wanted that described. You can reference a little picture, and if you have more complicated things, then go to the drawing.
Now, is that something you have to type in some, or is that something that's...
Yeah, I typed that in. So just for those pieces.
I've tried to do like in Excel where you could say, okay, if there's an if there's an angle 1 and an angle 2, you would put it one way. If there's only an angle 1, it would say a different thing.
Yeah, I haven't tried that either. Most of the time I really would prefer that they would look at the drawing. Except for that drawing. So these views are created as relative views. How many people know about relative views? Okay, half. So if you right click in the sheet, drawing view, relative view, you can insert it a couple different ways. I'll click in my main ISO view. This is the one that my cut list is linked to. It'll take you back over to the part. And this is more powerful than a regular view where you select bodies because it lets me set up the orientation right as I'm choosing the piece. So if I want to create a view for this, I selected that body, then I can choose the orientation. Now I have a view I can project from it. And so this will update as I change my model. There is a limitation in that if the orientation of my model changes, where this top piece that I just added, if that comes in on an angle now, then I would need to recreate the view because it will come in on that same angle. You could do a rotate view and kind of fake it out that way too, but I would say it's probably easier just to add the view again.
Can you edit that view feature and redefine it?
You can redefine the body that's chosen, but not the orientation. So that's a limitation I wish they would address. I can go in and select bodies and get a different body, but it's going to be in the same orientation as what I originally chose.
Can you try something for me once? Can you right click on that view?
Sure.
You right click on the view in the feature tree. Edit feature.
Just
Right.
takes me to the properties.
Never mind. Sorry.
Yeah.
I thought I saw that before.
Yeah, you can recreate it. Generally, I only have a few dimensions. One tip that I would say too when you're creating these views is to right click and go to properties for that view.
Off to your right.
Oh, here it is.
No.
Link balloon text to specified table. If if you're using, the reason I did that is because I added a balloon to my body, which is nice, and that refers back to the cut list, but I've had where this gets a different count of bodies and we'll actually have a different balloon number there in that view. But if you make sure that it's actually linked to the correct weldment cut list, then you won't have to worry about that issue. So let's look at this is what a profile looks like. In a moment there. It's just a sketch in a file, and it has a property called description. Whatever's in this description is what's going to show up in the description for every item in your weldment cut list that uses this profile. I recommend linking this text to your dimensions here, because it sure makes copy and pasting these to create new profiles a lot easier. I should also mention too that they now have configured weldment profiles, so you can have a bunch of configurations and the implementation is pretty much the same when you go to use them in your structural member.
Is there a way to get the length driven parameter in your profile?
The length. What do you mean by
You
that?
use that profile and you extrude it 12 inches.
Yeah.
Is there a way to set something in here that will automatically populate with what that is?
Not in this, because this file, this same profile will be used all over the place in different lengths. You would use the length. It doesn't have a length until it gets used in a part.
Right. But I mean, could you like put something in there that would then assign that once it's there?
I'm not sure if you could. I don't know. That sounds kind of backwards to me. I don't know why you would want the part to talk
I do
to
a cut list and
the
I height,
profile.
area, height, thickness, and length in one line.
Oh, I see.
You know,
Get
separate the
that
length
length
out
in there
because
copy and paste.
it's not the full description.
Yeah, I would probably use a custom property in the part to combine those instead.
Yeah, I mean, that's what I do now.
And you can use a custom property added to your weldment cut list. But I still say the profile itself doesn't have a length until it gets used in a part. So if it had a length property of some kind, you wouldn't want that to be populated in itself. I understand why you want to show it in the same field, but okay, so the other thing about this is the folder structure. Have you guys made your own custom profiles at all? A lot of you, good. So go and find those. This folder structure is really important. So any other questions?
How many of these come with or SolidWorks?
Almost everything you see here
Is it
comes with it.
It's a lot.
Is it?
Can you show an
You
example?
have to
of
down,
your-
you have to go through additional steps to download.
Oh, you downloaded more here.
Can you show a configured one?
I don't know if I have one.
They're pretty slick.
I really like them, but I work at a company where I'm not the only person, so we all share these profiles.
So what are the new things with this 2016?
Oh, I don't know.
I don't have that one in there. So I thought it was going to be new stuff, because I was excited about actually.
Oh, about new
coming here tonight.
Yeah, it's-
changes
It
for.
seems as weak as it used to be, unfortunately. That's
Yeah, I
not their
don't-
fault, but I mean, it just, some of these limitations the guys are asking are, yeah.
They're old limitations.
Yeah, yeah.
I agree. I still think this is much more powerful than an assembly of
Down
pieces,
here.
because you're going to have to change that over and over again, all of your different pieces. Even though the length is driven, the
But
profiles
the problem
aren't.
that we have is that we don't have a numbering system, so we only have like an Excel, and that's the part number pretty much. So D1, D2, D3, that's what we call it.
Mhm.
And we like to use those components all over the place, and
Yeah.
like this I wouldn't be able to. Like,
One of the biggest things with this versus an assembly is, for example, if you did want to change one of those corners in here, you just simply change the corner
Correct.
in
This is
here,
a lot
everything
easier.
is updated. Whereas in the assembly, you're gonna have to go in, there's two parts in there that you're gonna have to replace the components, create new parts for it,
You have to
and
make
all
it
of that
and
type of
everything.
stuff. So it's a heck of a
Yeah.
lot more work to change something
yeah, I've done
like
it
that.
both ways, but I thought someone told me that SolidWorks came up with a way where you were gonna be able to actually remove the components from the weldments. And I was misinformed.
You can save the bodies as parts and keep them on your tap and stuff to them.
Yeah, so he's bringing up a point too. You can actually save these bodies out as parts and keep them linked if you need them for some reason. Even a group of them together. So,
If you need to export them for laser cutting or something like that, you can save them as parts.
yeah.
They're still linked.
But can you actually name them in here?
You name the external file when you save it as a part.
But you can you can rename that cut list item 1, 2, or whatever you want to as well.
It's getting there, but it's not quite to what I needed it to be.
So at
We
that
need
point-
part numbers
at
and
this
we'll
point,
have
you
them.
would
so.
save selection? Is that how you would save that out?
No, that would save just the selection that I've made. What I want to do is, oh, where is it?
Down at the bottom there.
Where?
So we just left that
Save selection.
Oh, you have to right click on the actual cut list item. I know, I don't remember.
Down like the one down.
And then the new part is a description.
Yeah, so I believe this is what we're talking about. Insert into new part. You can bring your properties with it. And you set your file name here. So this is my linked subcomponent with those weldment pieces. It has its own cut list.
But you have to create it, doesn't do it on its own automatically.
Right, you have to
I
say
kinda
which things you want external.
I heard someone tell me something about you'll be able to just right click on it automatically. That's why I'm here.
I see.
But it seems like it's still the same thing. But
Yeah, I don't know. I haven't
this
had.
one is quick. You can make changes to things and use
Right.
it all over the place.
Yeah, it's very nice for the automatic trimming features too, and setting up the corner treatments.
To correct the compass.
Yeah, so if I had this cut set up, and then I'm, let's see, if I change this dimension here, actually 3-4 components all change their lengths, which you might not have even realized this one was gonna, well actually that's the same length, it just moved. This one relocates, those two get longer, this one gets shorter, so that's the main power of it there. And generally speaking, I don't want individual components for most of this stuff. It's only going to get cut one time that same way. We might cut this thing again sometime, but it's really not important to call it the same thing next time. Somebody's going to sit there at the saw and cut all these pieces that I need. And so they're just working off the one drawing to cut those. If that's not your workflow for your organization, then that definitely is a difference. Any questions? Yeah.
If you're gonna integrate like a sheet metal part, how would you do that? Yeah.
Yeah, so I would, It depends on how you're going to use that sheet metal part. Again, it comes with talking downstream. At FOG, I would probably have to do it separate because of the way we outsource our sheet metal, a lot of it. And they really want, you know, one separate file with nothing else attached to it. So that follows in that example. But you know, I've worked places where a lot of them are internal anyway. I can draw right on the side of this thing, sheet metal, and I don't know what I want to draw exactly. Okay. So, there you go. Whatever random shape. Create it as sheet metal. Pull in your gauge table. And I put it the wrong direction. Okay, so that's going to show up in your cut list as a sheet metal cut list item. It's going to have all the normal sheet metal properties, bounding box, everything like that.
So if you needed a separate file, you could.
I could save it out from here,
Separate part and send it to the sheet metal job.
which maybe I'll work on them on that.
You can also do an external and insert part into a weldment like that.
Right.
But you can do that, you know, it's how you're doing the separate views, you know, if you've got to make a separate sheet metal
Yeah.
drawing, I do that all the time, where, you know, if you got a frame and you put like a drawing or something like that.
So he's pointing out too, you can make your own, you can make a drawing. Should be able to, I'll create it the same way. You can make a drawing with a separate sheet, go back and reference that one sheet metal. Have to choose an orientation. And once you have the sheet metal component, where did I put it over here? There's a lot of ways to move views between drawings, but I like copy paste for some reason. Once you have a single body, okay, I'm going to go back.
You can do a flat pattern that way.
Yeah. You can do a flat pattern, but you can't do it as a relative view. So I have to do a model view of it. Insert it in. Select bodies. Choose the body. Then you'll be able to get a flat pattern. There you can see. Oops. Flat pattern shows up as an option there for that view. All right, those are good questions. I like that. Anything else? How are you guys using Weldments that you run into issues with them?
We do a lot of foot pads, so I've got like a welded profile that I stick in as a foot pad. Pretty handy to save time.
Oh, okay, yeah.
Caster pad, if you use the same size caster pad. I drag it and drop it and put it on the bottom of the tubes.
So he's saying that he, rather than the method I used here of adding something as a part at the assembly level for add-ons, because I wanted to be able to process that as a separate part, you could also make a custom profile for it with the part number built into that description and pull that through your weldment cut list. So whichever works better for your organization, the way that you want to process things. Yeah.
When you do a pack and go, does it take the profile with it?
The profile, whether he's asking if you do a pack and go, does it take the profile with it? No, but the profiles are embedded. I'm sorry?
So if I had a custom profile on my machine and I sent you a pack and go file, I'd send you the weldment?
No, you wouldn't have to send me anything but the file.
Okay.
So the profile is embedded in the feature once you use it.
Okay.
The problem is, if I had a bunch of them, and they're all my special tubing profiles, and I want to send it to somebody, they won't be able to change it to a different one of my custom profiles, or even reuse that profile. As long as they don't edit it, it's there.
Yeah,
Now, with some of your coworkers, does anyone does a lot of top-down assemblies where the sketches write everything? Or?
Not a lot,
But
because
it
of the
is a
way
good
we work
practice,
together.
though, right?
That's what's that?
That is a good practice, though, right? To
I-
do it that way, it gives you less limitations. I think.
It's nice, especially, but it all depends on how your files are going to be used. So he's saying, why not use top-down? It's so nice to have everything all linked together. One of the problems we run into is the way we use a PDM. People are searching, pulling down any one of those components and putting it in their assembly, not realizing that it could change based on the other assembly. So you have a big headache there of trying to track down where this piece was used and where the broken references are connected. And that's generally the approach that we use. Is you can use top-down, but you don't want to leave those relationships intact on your final released thing. If you're doing stuff that's more of a job where you're going to design the whole machine, release it, never look at it again, or maybe do a pack and go to make a new machine from that one, but you're not going to reuse those files in multiple assemblies simultaneously, then top-down is very nice for that.
Well, we reuse them, but we rename them.
Okay, yeah,
Because we don't have this numbering systems, so it's just like
right,
we'd rather same thing in different times.
yeah. Yeah.
One nice thing that we do, that we didn't do at first was basically start weldments. So if you got a weldment type that you do a lot of times, maybe like a weldment on a tube with a plate on it, you can actually save those as start files, and you can actually do, start up right from there from scratch. All the information is inside of it, so you can make changes, make it bigger, shorter, taller. Kind of a cool thing to do.
Yeah, so he's given a suggestion. One thing they do is they use sort of starter files for weldments, and you could apply that concept to any kind of assemblies or parts that you use in SolidWorks as a standard thing. So if you have a certain arrangement that's common and a lot of people are just going to pull that and stretch it a little bit and change it, you have those files to start from. It's a good shortcut.
That's what we're doing the same thing.
It does. It's nice. It does require maintaining those starter files, but in the long run, you save time because of everybody not drawing from scratch. Anytime you can reuse data, that's a good practice.
There's pretty small files.
A weldment file? Yeah, like this. Let me show you. In here, the main part is 717K. So I don't know, maybe that's small. That's pretty small to me.
That's
But.
pretty small.
How does a weldment bill of material integrate into like a full machine bill of materials?
If you're using like an indented or
You have to do it indented and then dissolve the sub-assemblies if you want a top-level parts-only deal on the cutlet.
so you want all of your cutlass members to show up in your top level bill of materials, yeah, you're gonna have to jump through a little bit of hoops to get that. It's doable.
Remember, it's the ass machine, even though it's not supposed to be.
Did that get fixed in 2016?
I haven't tested it yet.
I heard rumor of that, but I'll have to
So here's one more trick that I actually learned this today, and I don't know why I didn't know this. If you have, let me see which one this is, 12. So when you do have to delete your view, and you say, oh man, all my dimensions I have to re-put on there because this got tilted, if you remember that discussion, you can actually drag your dimensions right from one view to another. If you hold down Control, click on the dimension, and drag it. Whoops, I have my view selected also. Let's go back. If you hold down Control, click on, deselect your view. Hold down Control, click on the dimension and drag it over to the new view. It actually copies it right to that view, to the same things that it was stuck to in that one. If you do a shift, it just does a move.
You can go view to view.
I'm sorry?
You can go to view to view in the same part, same way.
In the, yeah. So do that before you delete your view that's slightly tilted, and then that'll
Wouldn't that
save
take
it.
longer?
I'm sorry?
Wouldn't that take longer?
Then just dimensioning it from scratch, maybe. Depends how hard it was to place that dimension, but yeah, you have options.
Yeah, it's hard to put dimensions. So.
If it's me, it might be quicker just to dimension them and use the smart rapid dimensioning to put it where it needs to go, but sometimes these angle ones are a little tricky.
A lot of times you pick a tangent when you do this.
Yeah. Yep. So, any other questions? I appreciate all the feedback and conversation. Hopefully you guys can, thanks. I'll post some things later on the website so you can watch the recording, and you can ask more questions there too. So, yeah.
Thank you.
Yeah.
Appreciate it. Thank you.